All right, this is a third example of chapter 6. It is question 118. Let's read the question first. Calculate the wavelength of light that has its third minimum at an angle of 30 degrees when falling on a double slit separated by 3 micrometer. So first, let's write down the relevant information. The distance between the slit is 3 micrometer. So 3 multiplied by 10 to the power minus 6 meter. We are talking about the third minimum. Now be careful here. We are still using m is equal to 3, but in this case, we're talking about the minimum, not the maximum, even though it's the same letter, all right? So what do we mean by the third minimum is if we look at the central maximum, this is the first minimum, the first trough. Second trough is the second minimum, and we're talking about the third one, this one over here. And we are told that this angle over here is 30 degrees. All right, now because we're talking the minimum, we need to use the destructive interference formula. So basically, it's nearly the same formula, except that m cannot take 0, it can only take a value of plus or minus 1 and above. It has to be an integer also. So here, this side, the left side of the formula is identical. The right side of the formula is m minus 1/2, close the parenthesis, multiply by lambda. Now, it's one formula, one unknown. This one is fairly straightforward. We plug in the value and we get 429 nanometer. The only difference here is since we're talking about minimum, we need to use the destructive interference formula. All right, so that's it for question 118. Let's go to the last example of this chapter.